Right, so now we continue our discussion on the particle in a box, one-dimensional with infinite potential. Well, right. So if this is our box of the one-dimensional length of L, so the energy is discrete, that n is a function of n squared. N is an integer number, 1, 2, 3. So you have discrete energy levels for this particle in the box, right? So also the condition is that because the electrons can only exist inside the box at different energy levels, so the probability or the description of the wave function at the edges here, at this point at x equals to 0, x equal to L, has to be 0, right? Okay, so we don't know exactly where the electron is between 0 and L, but we can predict its probability, right? And its probability is described by the integration of the wave function times its wave function conjugate and dx. So if you want to know from 0 to L, this product has to be 1, because we know that the electron has to be inside the box, right? It cannot be outside the box, right? The probability of finding the electron outside of the box at x lower than 0 or x higher than L is 0. So the wave function value is 0. So 0 times 0 has to be 0 then. Okay, so because in the wave function there is no description of, there is no imaginary number, so this would just be the wave function square dx, right? And the probability of finding it is 1, because you have to find the electron inside the box. So all you have to do is to solve this equation to find B. Okay, so let's do that. Now when the psi x is B times since n pi x over L, so that's 1 from 0 to L, B sine n pi x over L. This is square dx. So B is a constant, so we can take B out. So this will be 0 to L sine n pi x L square dx. Okay, so at this point we have to use a trigonometry law, right, where sin square x is equal to this term, okay. So this is a trigonometry rule, that this term is the same as this guy here. Alright, so now you can integrate for this term. B squared is B squared is a constant, so you can take this half also as a constant. So at the end you have here x minus L 2 pi n and sine 2 n pi x over L from 0 to L. Okay, so let's continue here. So in this case we continue the integration 1 is equal to b squared over 2 yep, this becomes L minus L over 2 pi n sin 2 n pi L over L, right? This is a double bracket, minus 0. Okay, I'm plugging in L and 0. Alright, this is L and this is 0, and this you can cancel out. Sin 2 pi n is 0, right? Sin 2 n pi is 0, so this becomes L minus 0. So 1 is b squared divided by 2 times L is 1. Alright, because we are interested to find b in this normalization procedure. So b squared is 2 over L, in which b is square root of 2 over L. Great. Now this procedure of finding the value of b for our wave function, it's called normalization process. Alright, and now we have a full description of our wave function, in which the wave function is square root of 2 over L times sin n pi x over L.